Hey y'all, this is just a quick video on inverse variation graphs and tables and just kind of walking through the process so we understand it a little bit better. All right, so let's start with the problem. It says the time t it takes to travel a certain distance varies inversely as the rate r at which you travel. The equation r times t equals 250 can be used to represent a person driving 250 miles. Complete the table and draw a graph of the relation. All right, so let's go ahead and just take a peek at what we have here. We know we have r times t equals to 250, and we can identify that r just stands for the speed, miles per hour, and t is going to stand for our time in hours. So we are given r, which is going to be our input. Now in this problem, we want to fill out that table. So we're going to go through the process of just doing this equation with some division each time. So I'm going to take r, which is 5, and plug it in for rate. And I'm going to say 5 times t equals 250. And then I'm going to divide by 5. T comes out to be 50. So I'm going to come in here and I'm going to say, okay, well, this must be 50. Well, now let's go to 10. We're going to go through the same process again. We're going to say, okay, 10 times t equals to 250. And we're going to divide by 10. And I'm going to say, okay, well, t must be 25. So this is 25. And then I'm going to say, okay, well, let's take 15. 15 times t equals to 250. We divide by 15. And t comes out to be some decimal value. We're going to find that out in just a second. But what you'll notice is every single time we are dividing by the rate. So we are dividing by the rate every single time, which is our speed. So if we look at this equation, r times t equals to 250, in order to find the time, we are going to be dividing by our rate, t equals to 250 over r. So let's go to Desmos. We'll set this up in a table so we can kind of look at it, make some sense of this equation. So we're going to add a table into Desmos, and I'm going to just go, I'm going to work my way down. 5, 10, 15, 20, 25, 30, 35, 40. 45 and 50. And then what I'm going to do is I'm going to come up here to the top of this table and I'm going to type in what we just figured out. We just figured out just a second ago here that to find the time, we do 250 divided by the rate. So I'm going to come over here. I'm going to plug that in. I'm going to say, okay, this is 250 divided by the rate. And what you'll notice is those rates are right there. These are our rates in our Desmos table. So I'm going to write 250 divided by x1. And notice what happens. It comes out. It fills out our table for us. And one thing you're going to really notice right away is that this curve is not linear. It's actually not even exponential, even though it kind of looks like it. What it is it is just simply an inverse variation curve, and it's going to work its way down and slowly approach 0. So let's go ahead and type in right down below our function, because it is going to say determine. See it right there, determine the equation that will overlap the data. Well, we've actually already done that. We have done that already. It is right here, 250 divided by r. We've actually plugged it in order to find the table. So let's come down here into the next cell. And what I'm going to do just to verify is I'm going to type it in as function notation. I'm just going to say f of x equals to 250. We followed the pattern in order to do this, 250 divided by x. So you'll see we have the data in table. And now what you'll notice is that it completely overlaps that graph. We can see that 250 over x is going to be our graph. All right, y'all, I hope that helps you out with setting up that table and setting up an inverse variation for this problem.